Hey everybody, what's going on? I'm Average and welcome back to another episode in A Beginner's Guide to Bun. Bun implements a built-in test runner, Bun Test. So for those of you who don't know what tests are, these are automated tests we can write. They're called unit tests, and they allow us to ensure that behavior is still working as it was originally intended to. Let's say a function works at one point in time, our getUsers function. We write a test and we ensure that the behavior works, and now anytime that test is touched in the future, we also still know that it works because they get run automatically before deployment or whatever. So how do we actually get this implemented? First off, let's create our Bun project with Bun in it here. I'm going to create a folder called source, and this is where we're going to put everything for today's video. So I'm going to be creating a new file. We're just going to call it math.ts. Math.ts is going to be super simple. It's going to have a export function add. It's going to take two numbers as parameters, and it's going to return a number. It's literally just going to add the two, nothing special. And then for our divide function that we have down here, same thing, similar parameters and return value. We are going to do a if b is equal to 0, and we're going to throw a range error if it can't divide by 0, and then it's just going to divide it. So pretty typical stuff. If you want to follow along, you can, but this video, I guess, would just be more about theory and showing off what Bun's test runner can do. So let's head into src and let's make math.test.ts, just like so. This is where we're going to write our very first test. So we can do that by just saying test and then calling it as if it was a method. Inside of here, the first parameter is going to be the name of the test. So we can say add two numbers, 1 plus 1 is equal to 2, we can say, and then we're going to use a callback, and this is actually going to be where our test code runs. We can import test from bun::test, just like so. Something you'll notice pretty quickly is if you've used Jest before, this API Bun test, I believe they're interchangeable. So if you have stuff written in Jest, you can easily swap over to Bun's test runner and get all the benefits of it, specifically the speed. Let's actually make sure our test is doing anything at all. So in math, all we need to do is call add, and we can say 1 and 1, and then this will actually just return 2. So we can say const sum equals and capture that value, just like so. And then we have to use a new method called expect. This is also from Bun test. And inside of here, we actually have to plop in our sum, just like so, or whatever value we want to be matching, it's called. And then if we do dot period, we get a lot of different types of matchers. And what a matcher is, it will throw an exception if the assertion cannot be made. So like if I say to be array, this will fail. I can actually run tests, all tests with Bun test. And you'll see that this fails. And if I read as to why it's failing, it says expect to be array. So it is not an array. It actually just received 2. So what we have to do is we have to change this to be 2. And now it will check, oh, is this value 2? And it will pass successfully. We can see that here, add two numbers, 1 plus 1 is equal to 2. Something I can also do is say to be type of, and we can put in number as a string there. Unfortunately, the way matchers work is this won't actually return a copy of the object or a reference of the object. So we do need to do expect sum dot to be 2 as two separate lines. So now we're checking, is this return value a number? We're also checking, is this return value equal to 2, which is our expected value from 1 plus 1. And if we do Bun test, that will work. If I make this, let's say a string, it will fail because we are returning a number and not a string. So let's say we wanted to do a bunch of different test cases of one kind of behavior. So something we can do is we can say const cases, and we're going to just call this addition cases because we will be using another one in a second for division. And in here, we're going to say 2, 2, and then 4. And the way that this is going to work is we're actually going to take first and the second value. We're going to add those together, and we're going to see if it matches the third value passed in here. We can also do something like 5, 10, 15. So 5 plus 10 is equal to 15. Let's do some negative numbers as well. -1 equals -2. So something we can do now is we can say test.each, and we can give it a name, and we're going to say add, and then we can say %i, and that's going to expect a integer in that placeholder, and %i to be, and then we can say %i again, going in the order of how it's displayed here. So add 2 and 2 to be 4. Each is going to be a method that returns another method sort of as a chain. So inside of here, when we do test.each, we can pass in our addition cases, just like so. In our callback, we are allowed to take in up to 3 values. So we can say a, b, and expect expected. So A and B, those are going to be our two values at the beginning of each array here in our addition cases, and then expected is going to be that last value. So what I can do is I can say const sum add, and then we're going to say A and B, and then we're going to say expect sum to be expected, just like so. Now, if I do bun test, you'll notice that we actually get all of our tests running there, just like so. So we get add 2 and 2 to be 4, add 5 and 10 to be 15, add -1 and -1 to be -2. Now we can continue expanding this with whichever test cases. And the reason why this is nice is because we don't have to write this out a bunch of times. Okay, so the next thing we're actually going to be doing is grouping. So what we need to do is say describe, and we can say math utilities. And what this is going to do, actually, we need to write out a callback and wrap all of our existing tests in this callback, just like so. Make sure you import describe from bun test. And what this is going to do is basically categorize this as a group that's called math utilities. When I do bun test, you'll notice here that we get this now. We get kind of a category, and within that, we get the individual test cases. And this also will allow us to do even more grouping. We can say describe, and we can say addition, and we can do a similar thing, wrap our addition methods with a callback, which are our only ones. And now if I do bun test, you'll notice that we get math utilities, addition, add 2 numbers, which is really nice. We get a lot of organization here with this. The reason why I'm doing this is because I can add a describe for our division function as well. We're going to write out a test, and we can write out a really simple test like this. Test should divide 2 numbers, and it's just going to divide 10 and 2 and expect the result to be 5, which is correct. So now if I do bun test, you'll notice here that we get math utilities, addition, add 2 numbers, all of the addition stuff. And then we also get the division one grouped separately there, which is really nice. It also lets us do something pretty nice, which is bun test, and then we can say -t, and then we can just say add. And this will only test all of our addition stuff. What -t does is it tries to match whatever you're giving it here as a pattern to anything in these descriptor blocks. So this would match add here because we are adding. It would also match these because we're also adding, but it won't match division because it doesn't have that word in it. If I type in division, and please note that this is case sensitive. As you can see here, now we only have the division group running here. All right, so the next thing I'm going to show you guys is what if we divide by 0? What if we are actually expecting to get this error and we want to test to see if we are getting the error when we should? We can write a new test. We're going to call this one should throw error when dividing by 0, callback, and we are going to do expect divide 10 and 0, and then dot to throw. This is another matcher. It's basically going to match a error as whatever we expect it to be. We can pass in range error there. And if I do bun test division, we get should throw error when dividing by 0. Okay, the next thing we are going to do is we're going to say const division cases, and we are going to be writing this a little bit differently because instead of arrays, we're going to be using objects. So what we can do here is we can say A, and we're going to say 6, B is 3, and then our expected will be 2. So we're actually giving this object some properties to work with. All right, let's do A 100, B 25. We should get 4 of those. And then we'll do a simple one, A 7, B of 1. So we should get our expected value of 7. And I need to make sure up here we actually say expected. Let's go down here and we're going to say test.each. And then in here, we're going to pass in our division cases. We also need to give it a name. Here, we can actually do the placeholders a little bit differently. We can use the variable or the property names themselves. So we can say divide A by B to get, and then we're going to say expected. Okay, and then inside of here, we're going to define our callback. We're going to use our variables here, our properties. To do so, we need to actually unwrap the main object because we are passing in entire objects to this array. So we need to unwrap what we want, which will be A, B, and then expected. Write out our callback just like so. Okay, and then we can say expect, and we're going to do this a little bit differently. We're not going to use a callback to get the value here. What we're going to do instead is we're going to say divide A, B, and then we're just going to say dot to be expected. So now if I test, we should get our math utilities division, and we'll notice our new looped tests here. So we get divide 6 by 3 to get 2, divide 100 by 25 to get 4, divide 7 by 1 to get 7. If I threw something in here just for fun, like 9 and 2, and we expect 0, for example, that will fail because obviously that's not what 9 divided by 2 is equal to. I just want to show you guys that it can fail if you're passing in the wrong things to your case here. Okay, I'm going to show you guys some life cycle stuff now. So basically, these are things that happen at certain events during the test running process. For the first one, we're going to use beforeAll. This is going to do anything you want. It just accepts a callback before any of the tests are run. So we can say console.log and we can say math tests incoming if we want. And if I do bun test, we'll notice before any of the tests are run, it says math tests incoming. We can also say beforeEach. This will actually run before each of the tests. Tests incoming. This is just going to create a bunch of spam because every time a test runs, it's going to say test incoming. There's some others. There's after all, after each. You can also have them scope to different groups. So let's say I wanted to have an after all addition. I could do that as well. If I really wanted to do this, I could make this test here a conditional test with .if. Pretty simple. Just do test.if. And then inside of here, you need a condition. So I can say math random more than 0.5. So give it a 50-50 chance on if we want to run that test or not. So I've run it a few times. It should eventually skip, as you can see there. It says one skip. I can also inverse this. So I could say skip if it meets this condition. I could just say 1 is equal to 1, like so, and that will always skip. But if I just do .if, the test will only run if it meets that condition. You can also do test.todo. What that's going to do is mark it as a to-do, and it won't run. It will also skip. If I do bun test and then I say --to-do, it will try and run tests that are marked with to-do, and it will even say this test passes, so you should remove the to-do if the behavior works now. If I want, I can also just force this test to be skipped entirely with .skip. Now, if I do bun test, it will just say one skip, and no matter what, it will skip that test there. We are going to create a new file, and we're just going to call it api.ts. It's going to be a pretty simple function. All we're going to do is await a fetch call to this endpoint here, JSON placeholder /posts. I'll put this in the description below. Basically, all it does is return some JSON data. It's a mock API, a free API to use. So we're going to be using this. All I need to do is just slot this in here like so. Then we're going to say .json after, because we are going to want to return our JSON data. If I go to our src folder, api.test.ts. By the way, I don't think I mentioned this, but anytime a file is labeled .test.ts, Bun acknowledges it. It says, oh, this is a test file. I should run the test in it. So that's how you tell Bun that, yes, this is a test file. And usually they're put right in the same directory as the file that you are unit testing. All right, so in here, we're going to start pretty simple. We're going to say API utilities, just like so. And we're going to be using a describe for that to create a test block or test category, however you want to call it. Inside of here, we're going to make a test called should fetch posts. We're going to give it a callback just like so. Make sure to import. And we're going to mark this callback as asynchronous. And that's pretty much all you need to do, because now I can say const posts equal get posts. And this is an asynchronous function, so we have to await that. So I can say expect.posts to be array, and that will ensure that the post, yes, we're returning an array. I can also say expect posts.length. So we're going to take the length of the array, and I'm going to say to be greater than 1. So we want to ensure that what we're receiving is more than 1, and it always will be. Get posts will return, I think, 100 posts. Instead of us getting promise of unknown, what we're going to do is we're actually going to make this api.ts return a promise of any, and now we won't get that error with the post.length, as it kind of just expects that to be there. If I want, I can make this a promise of type any, and then I have to cast this again as an array of any, as a promise of an array of any, just like so. And now it will understand that this is an array, and I can do array operations on it. If I do bun test, you'll notice that we get that first. Now we get API utilities should fetch posts, and this runs in 185 milliseconds. Something else I'm going to show you is we can actually give tests a timeout. If I say only 100, that test is now going to fail because it timed out after 100 milliseconds. If I say 500, for example, the test will succeed because it was successfully completed within 500 milliseconds. Instead of just passing a number, a magic number, I can pass an object, and I can say timeout 500 instead, just like so. Something else you can do is you can say retry, and I'm going to pass in 3. So what this is going to do is it's going to retry this test 3 times if it fails, which I think sometimes is useful if it is a network that may be kind of faulty. That's what you're testing. Then maybe you do want some retries. I don't know. It's up to you. Okay. The next thing I'm going to do is I'm going to make a new file, and I'm going to call this time.test.ts. This is actually going to be only one single test. This is going to be be based on time operation. Okay, so I'm going to make just a test called is 5 minutes after December 1st, 2025 at 12 p.m. And so what does this mean exactly? We need the time to be December 1st. This test is dependent on a specific snapshot in time, and Bun allows you to do that. They allow you to set system time just like so. We can say new date, and I'm going to say 2025 12:01 T 12:05 00Z. So that's going to set the system time to what I've input here, which should be 5 minutes after 12 p.m. December 1st, 2025. And what we can say is we can say const now equals new date. Anytime we make a new date now, it will be this time. So there's everything we need to check if it is December 1st, 2025 at 12 p.m., but 5 minutes after. And if I run this test now, passes successfully, and then I also need to set the system time back after it runs just by doing set system time, because otherwise the tests that may come after this will think that it is this time. So for example, let's say I don't do that and I run the test, it will fail because obviously it's not that time. So this basically tricks Bun into believing that the time is whatever you set here. This is important if your test is deterministic on time. Okay, the next thing we're going to do is I'm going to make a new folder called components, and we're going to use this folder to test React components. So I have a button.tsx here. It's a really simple button that just has a button and then it passes in children. What I do need to do is bun add, and then I'm going to add happy dom / global-registrator, just like so. And I also need to add two other libraries. I need to add testing library / React and testing library / jest-dom, just like so. And let's add those as developer dependencies with the -d. And something else I can do is type / React as well. All right, so the first thing we need to do is we actually need to set up a preload for our bun tests. And we can do that by creating a new file. We're just going to do it in our root, and we're going to call it happydom.ts. Inside of here, we're just going to call global-registrator.register. What this is going to allow us to do is basically emulate a DOM, a web browser DOM, so we can do things like DOM tests with React components. However, what we need to do is actually create a new file called bunfig.toml. And this is actually Bun's configuration file, which we haven't looked at yet, but we're going to look at it here. It's not super important, to be honest. All we need to do in here is make a change to the test domain, and we're going to do preload equals, and then we're going to give it ./happydom.ts. And what this is going to do is on tests, we're going to preload this happydom.ts, which just sets up our emulated DOM. And if we head over to our button.tsx, you'll notice there are no more errors. If I make a new file called button.test.tsx, just like so, this is now going to be where we add our test. So we can describe, and we can say React components, just like we would with a normal test here. And we can say test renders button with correct text. And the reason why we're saying that is because we can pass in any text we want to this button. Inside of here, we're going to say render button click me. And essentially what this is doing is it's going to add a button to the DOM. I'm going to add these missing imports here. Render comes from testing library / React. And then obviously our button is our custom button, which is not a type. There we go. So now we've added a button to the DOM, but we haven't actually done anything with it. So what we need to do is we need to say expect screen.getByRole, and we're going to pass in a string of button. It's the only button in our DOM, so we can use this. Screen will come from our testing library React, so make sure that you import that. And now what we're going to say is we're going to grab the inner text of the button. Okay, and then we'll get this error here, which says blah, 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 try changing the lib compiler option to DOM. What we need to do is up here, 3 slashes, and we're going to say reference lib equals DOM and close that off as you would with HTML or XML. There we go. So now the error goes away and we can get the inner text of the button, and we're going to expect this to be click me. So now if I do bun test, we will get renders button with correct text. If I change this to just me or something and break the test on purpose, that will fail. And this just goes to show that we are actually using and handling DOM entities here. Okay, now Now for the last part of this video, we're going to create a new folder and we're going to call it DB. Inside of here, we're going to make a interface called idbconnection.ts. This is going to be an interface, IDB connection. We're going to have one method on here and it's going to be query. It's going to accept any type. We're going to pass in some SQL parameters if we want, and it's going to return a promise of type T array. This is a proof of concept. We're not actually connecting a database here. We're going to be doing something called mocks. So we are going to expect this IDB connection to function a certain way, return a certain value using essentially fake data. So if we were to use a real IDB connection, let's say SQLite connection, MySQL connection, whatever we want, we're expecting those that are implement this interface to function in the way we're about to mock up. All right, so what I'm going to do is I'm going to create a new file, user repository.ts. All right, and in here, we're going to create a user type, just like so. We're going to have ID, number, email, string, whatever, password, string as well. All right, and then we're going to make a interface, user repository. We're going to find by ID, give it a number, promise, user, or null, right? And then we have a save, which is going to save a user to the database. It's just going to be promise void. All right, and then we're going to export a class user repository. And we're going to implement our user repository here, just like so. User repository, that should be okay. And then it's going to complain. Let's do a quick fix and implement the interface. Up here, we're going to need to change this to type. And then as you can see, we have our empty methods. Let's actually give them some functionality. What we need to do first is pass in our read-only DB IDB connection, like so, and then just give the constructor an empty body like that. Our find by ID, that's going to be asynchronous, and it's going to be const user equals await this.db.query, and we're giving it a query that would work, and we need to give it the user type. We're expecting a user, and now we need to pass in some SQL to actually get our user. Select ID, email, password from users where ID is equal to, and then use a placeholder, and then pass in array with the ID like so. All right, and then we need to do return user or return null, just like so. Basically, this isn't really even fake, but the way that we're going to be setting up the database is going to be fake because obviously we aren't going to have a database connection. We're going to mock the connection part. All right, for the save, we are going to do await this.db.query. All right, and then we're going to insert into users. We're going to give it all the columns it needs, values, and then placeholders for the columns, and then pass it in as an array at the end there. Also, need to change that to asynchronous there. Okay, so we should have a fully functional user repository here that in theory would allow us to fetch users if we wanted to. I'm going to create another file and we're going to call this user service. We're going to use this to fetch our users from the repository. So give it a constructor. It's going to accept a user repository, and then we're going to have a get user where we find our user. And if the user doesn't exist, throw an error. And then as well as that, we're going to have a register method down here, which just saves the user that we pass in. All right, so let's make some tests for this, okay? So what we're going to do is make a new file. We're going to call it user repository.test.ts, and we're going to have a test user here. It's going to be of type user, and we're going to need to give it some properties that match the user. So ID, we're going to say 1. All right, next. So we're going to say describe user service tests and give it a callback, import itself. So our first test is going to return a user, and we're going to do asynchronous. All right, and then this is where we're going to do some mocking. We're going to create some fake stuff so we can use it in place of behavior, because what mocks are for, they're meant to basically just kind of fake an area of something so we can test another area and make sure that functionality works. So we're going to mock our find by ID, and we're going to do this by saying mock, and we need to import this from bun test, and then async ID, that's going to be of type number, and we're always just going to return our test user. All right, so for our repository, which is going to be of type user repository, we are going to make a fake one here. Obviously, we're going to mock this. So our find by ID is going to be that. And then our save function, we don't even need our save function for this part. So we can still mock it. We're going to have to because it needs to exist, but we're not going to make it do literally anything at all. So here's our mock user repository. We have a find by ID, which will always return our test user. And then we can actually give our service, our user service, our our mocked fake repository. And because user service works off of the user repository that we pass in, it's just going to think that we can find a user. And so we are going to need to await this, even though it's actually not asynchronous here, the iUser repository will be a promise. So it's good to await this just in case something changes. We can say expect service dot get user, and then we're going to pass in any number we want. We can say 1. Make sure you import expect, and we're going to say that the promise resolves to equal and then our exact test user. So it should just give our test user back to us. Another thing we can do is we can say expect find by ID to have been called times 1. So this just basically says find by ID should have been called 1 time. No more, no less. This mock method that the user service will eventually use should only be called 1 time. As well as this, we can also expect our find by ID, which is our mock method, to have been called with, and then this is where we're going to say, okay, these are the parameters we expect it to have been called with. So in this case, we can just pass in a 1 because we're looking for the user ID 1. So pretty simple. I know it might be a little bit confusing if you've never done any mocking, but basically we're just faking specific parts of our test so that we can isolate the functionality exactly of the get user. We're kind of just making sure this exact logic works, expecting everything else inside of it to work. Like any dependencies like iUser repository, that just works. Always it will work, and that's the point of a mock. Hopefully I'm explaining that okay. We're going to do a couple more examples of this. Let's say we want to mock the saving. So we can do a very similar thing, right? We can make const save equal mock, and we're just going to give it the async user, and we're not even going to do anything. We don't need to do anything, right? We're just ensuring that our user service can register a user, and its own logic here will run properly. It doesn't really have any logic. It's super simple, but let's say there was some more advanced logic in here, like, oh, I don't know, the user email needs to be certain constraint, whatever. That's the logic that we're testing. We're not testing that the dependency, the user repository works. We're testing that this individual method works if every dependency is working, and in this case is mock. And that's the whole point of a unit test, right? It's not the entire system, it's an individual small unit. If we were testing the whole system, that would be something called an integration test, which is a bit different. This video is just about unit testing. Maybe one day I'll do a video on Solid. It's basically 5 principles that people use to ensure that your code base is very testable and usually maintainable, but you know, sometimes you can go a little overboard. That's besides the point. This is just another example of mocking a specific part of a dependency so that the thing that we're actually testing, user service, will work. Okay, next up, we're going to be trying out something called spyOn. Let's make another test and let's call it receives user. We're going to just do in brackets spyOn to show that this is going to be using spyOn. And so I've written the code quickly here because I don't want to kind of bore you with me just typing stuff out. I think it's better if I just explain it as a whole. So we have our IDB connection, which is mocked. Basically, this is just going to return an empty array as whatever. That's not important. That's not what we're focusing on. So we have this repository here, right? And we're using the DB connection. Let's say our repository was kind of a global repository. So if I put this up here, let's say that this repository was accessible from anywhere, all over your project. You have like maybe a static get instance singleton pattern, and you can get that repository whenever you want. What we can do is we can actually use something called spyOn, which is a method, and this allows us to give the reference of whatever we want to spy on, and then also the method name, in which case this is going to be find by ID. So we're basically spying on this repository and seeing if anything calls find by ID. And if it does, we're going to force it to return a different value, something we want. We're basically kind of like a man in the middle attack here. We're going to return the test user that we want to return, which has been defined up here. So we can create a new service with this, and then we can just use the similar logic that we used up here to call our get user, and it should resolve to our test user, because essentially, again, like I said, we're forcing our global instances find by ID to return this value. This is a bit of a simpler way of doing it, but the issue with doing it like this is once we do this, it's going to always return test user. So we've basically broken the logic. If anything else is using this and expects it to work normally, as it should, as the global instance, then it's going to always return this test user. So what we actually have to do is we can do this anywhere. We can do this within our describe block, or we can do it up here. And we're going to use a lifecycle hook after each, which is going to be a callback. And it's really simple. We're just going to say mock dot clear all mocks. And that's just going to make sure that our mock that we made down here, our spyOn, is kind of just non-existent after this test runs. Hopefully this part made sense, guys. I know it's a little bit more abstract, but it is kind of important when you're doing anything really with tests and different abstractions. You want to be able to isolate specifically to the unit that you're trying to test. In this case, it's kind of a bad example because I'm just receiving a user and there's no logic really to test. For something like saving though, maybe we have a completely valid user and we want to test the validation that user service may be doing. I don't know. It could be something like that, but essentially this is how you do mocking in Bun's test runner. Hopefully you guys already understand mocking and why it's used, because otherwise this part may be a little bit confusing to you, but it's good to be exposed to it regardless. With all of that being said, that's the end of today's video. I hope you guys enjoyed, and if you did, please make sure to leave a like, comment, and subscribe. Let me know what you thought of this video, and I hope you guys have a great day. Bye.